Hey, welcome. Today, we're going to open up the Programmer's Toolkit and really demystify the absolute fundamentals of C++. If you've ever found yourself wondering how an app or a piece of software actually thinks, how it makes decisions, well, you are in exactly the right place. Let's dive in.
Just think about this for a second. Every single time you log into an app, it has to make a choice. Is this password right or is it wrong? That really simple decision is powered by the exact building blocks we're going to talk about today. It really is all about teaching the code how to think.
All right, so the first tool in our toolkit is the language itself. See, just like any language, C++ has its own special vocabulary, words that have a very specific, built-in meaning. We call these keywords. And that word, reserved, is super important. These words are like the bedrock of the language. The compiler, that's the thing that translates our code into something the computer can actually run, has these words hardwired into its brain. That means you can't just use them for whatever you want. They have one job and one job only.
So what do they look like? Well, here are just a few of them. Some, like int, char, and bool, are all about defining different types of information. And others, like if, else, and for, are what we use to control the program's flow. They're the words that help it make those decisions we were just talking about. And don't worry, we're going to see a few of these in action real soon. So let's grab our next tool and see how this all connects. Once we have our special words, we obviously need a way to store and manage information. A program isn't very helpful if it can't remember anything, right? And that is where variables come into play.
I absolutely love this metaphor of a label box. When you create a variable, you're basically telling the computer, hey, can you set aside a little piece of memory for me? Slap a label on it, because I'm going to put something inside. It's how a program remembers stuff like your username or your high score or how many things you've got in your shopping cart.
But, not all boxes are created equal. You need different types of containers for different kinds of data. An int is for whole numbers. A float can handle decimals. A char holds just a single letter or a symbol. And then there's bool, which can only ever hold one of two values, true or false.
All right, so we've got our special words, we've got our containers for data. What's next? Well, now we need a way to actually do stuff with that data. We need action, and these are the verbs of our programming language. We call them operators.
So the big idea here is that an operator is just a symbol that acts like a trigger. When the compiler sees a plus sign or maybe a greater than sign, it knows it has a specific job to do, either some kind of math or some kind of comparison.
And you can kind of split them into two main groups. Over on the left, you've got your arithmetic operators. That's your basic math. But on the right, you have relational operators, and these are so important. See, they don't give you a number as an answer. They give you a true or a false. They ask questions like, hey, is this value equal to that one? And this is where it all clicks. This is where the magic happens. We've got our data sitting in its containers, and we have symbols that let us ask questions about that data. Now we can combine them to give our program, well, kind of like a brain. This is decision-making.
This is how you make software that feels smart and responsive. Decision-making is what lets a program react differently to different situations. It's not just a dumb top-to-bottom list of instructions anymore. It becomes a dynamic process that can actually choose its own path.
I want you to think of it like a fork in the road. The if statement, that's the signpost at the fork. It asks a question that can only be answered with true or false. And based on that answer, the program either goes down path A or turns and goes down path B instead.
So let's look at the question itself. This little bit of code right here is the absolute heart of the decision. Here, A and B are our variables, our labeled boxes, remember? And that greater than symbol, that's our relational operator.
And that's all it's asking, just in plain English. The parentheses in an if statement always contain a question that's going to result in either true or false. The computer does the comparison and it gets its simple one-word answer.
And now you can see the whole structure. If the answer to that question is a greater than B is true, then the code inside the first set of curly braces is what runs. But if the answer is false, the program completely skips that part and jumps down to run the code in the else block. It's one question, but two completely different possible outcomes.
Okay, so we've looked at all the individual tools in our toolkit. We've got the keywords, the variables, the operators, and these decision-making structures. Now let's put it all together and watch how these separate little pieces create a real, functioning piece of logic.
We're just going to trace the logic of a tiny little program, step by step.
And as we go, you're going to see exactly how the keywords, the variables, and the operators all work together to make a choice. I promise, this is going to make it all click.
So let's break this down. First, the program creates our integer container, our box. It labels it A, and it puts the number 100 inside. Then it gets to the decision point, that if statement. It asks itself the question, is the value inside A less than 20? Well, since 100 is definitely not less than 20, the answer to that question is false. And because the answer is false, the program follows the false path. It skips the first block and executes the code in the else block, which prints out that message. You see? It's a complete logical story, from setup to decision to action.
And there you have it. These 4 concepts, keywords, variables, operators, and decisions, they are the absolute foundation. They're the nouns, the verbs, and the grammar that let us talk to a computer and tell it how to do amazing, complex, and dynamic things. You know, every complex app, every incredible video game, every piece of powerful software you've ever used is, at its core, just a really clever combination of these simple building blocks, scaled up thousands or even millions of times. So the real question is, what are you going to build with them? Thanks for listening.